Yes, recording has started.
Excellent. So this is the our third meeting, actually, of this great endeavor, to my opinion, of the Journal Club in the IAIMS community context. So today's, let's say, today's session title is AI in Clinical Workflow, Technical and Stakeholders Perspectives. And I would like at this point to just introduce our two great speakers. So Mary Bach and Delphine. Okay, so Mary Bach is an electrical engineer and associate professor at the Faculty of Biology and Medicine of UNIL. She has great experience on trustworthy medical image analysis and leads the medical image analysis laboratory at CHUV. So regarding Delphine, her work spans research and real-world applications. She has a strong background in electrical engineering and expertise in medical image processing. She is experienced in. She works in. She has experience in research labs and healthcare settings. I don't know if I covered everything, but if you have anything to add, please do so. Just a couple of rules that you may all know. We need to actually. We're only 6, but I guess if we have a question, we can just raise our hands and just to keep track of the order. And what else? I think that's that from me.
Definitely.
So the floor is yours.
So I will share the screen again. It will come in a second. And as I was saying before, I don't see anything when I'm sharing my screen, so just interrupt me if you have any burning question or comment. Just stop me.
I can see your screen at least. So.
Yeah, like this would be better. Do you see the full screen?
Yeah.
Yeah, super. So yeah, and thanks a lot for the invitation. And I agree, I think it's an amazing initiative. So I'm happy to contribute and collaborate. And we are both very happy to be here. Now I see this thing appearing. I don't know how to remove you. I will minimize you actually. I don't know. Minimize? No. Do you see yourself? Or no? Oh, no, okay, then I don't care. I have you. Okay, so today do you see the slides moving?
No.
No, me neither. Okay. Now. Yeah, so today I wanted to, of course, start with what it is in general, the research goal that we have in the context of the application of MS. That is one of the domains of applications I work on. It is really to develop responsible and trustworthy behavior of machine learning algorithms, mostly focused on neuroimaging. So we will see a lot of MRI today, and that really aims at supporting the diagnosis and prognosis of the patients. And why we rely on this trustworthiness, because we believe that is really something that has a win-win-win situation at different levels, at the levels of engineers, and I will show you today how we can use this setting to improve our models. We hope actually that this framework would increase the quality of the decisions of the doctors. Delphine will dig more into that. And as well, ultimately, we believe that this can really support a better understanding of the disease and as well the mechanisms. And maybe one comment, just to have you all in the same page about trustworthy AI, why we heard a lot. Okay, here you are biased because you are here in this journal club, so you probably know, but it's really about these core principles that here I describe in these categories. and I was not the first. It was already done by Future AI initiative. And the idea is that you have these core principles that are actually aiming to quantify blocks and pieces where the stakeholders can rely on. And these, you have to see them not as independent components, what you see here, but as well core principles that may span to different categories. And I think this is very important to understand. And of course, why now and not before? Well, now we have these barriers for the adoption, and we have as well more risks. So in the context of the healthcare, we believe that all these aspects are really important. So the way I pitch this type of research, or why, is because, as I told you, we have now these premises of, people say it AI, me, I call it machine learning, that becomes more and more complex. And in this query of complexity, we have more black boxes. So it's about the model. We need to really unlock now the contents of this black box and add some layers of explainability and uncertainty that I will be talking today. But it's not only about the model. It's as well about the stakeholder, right? It's how then this stakeholder will adopt this in a clinical workflow, and how it is adopted in a long-term manner, because we want to have things that really stay in the durability. And this is a matter as well of calibration of trust, that it can be in the two senses. And in the context, of course, of AI, and I will call it AI because everyone calls it AI, what it is important is about the data. In medical imaging especially, data is complex, access is limited, sometimes annotations are precious and often needed, and it's important to have a criteria of the quality. And it is not only about the data, it is about the data and the model and how they interact, because more deep learning algorithms suffer considerably of what we call domain shift, and the fact that we have all this heterogeneous setting, and that we have as well diseases that are sometimes with different prevalence and biases and very heterogeneous. So it's about all this. And what I wanted to present today, it will be mostly on the context of MS, because we are in this journal club. And what we have been exploring in the last 4 years, now we are concluding the project, is a little bit of these core principles of trustworthiness in the context of the assessing the progression of MS disease patients through MRI. I will only talk today about the uncertainty. And so this is the team I want to credit that has participated in the past and in the last 4 years on this research. Maybe that slide, I would avoid it here. I'm a little bit ashamed to present that. This is my one slide pitch about what it is MS in one slide. But the idea here is just to say, okay, neurodegenerative brain disease, we don't have a cure, but we have treatments. But these treatments come really with important decisions on adaptation of the treatment that has to be adapted all through the years. And these treatments have very heavy secondary effects sometimes. So the decision of changing the treatment is a very important one. And we have as well some biomarkers like this NFL chain that come more from the CSF spinal fluid. But we have in our context the MRI as a key workhorse to track the dissemination in time and space of these lesions that MS cause, right? So if we gather together AI and MRI in MS, what we see basically is that there is a boom of data that has to be explored. You have images, MRI images for the brain, for the spine, and now from the optic nerve. You have classical clinical sequences, but you may have as well other quantitative imaging contrast. You want to have a look, particularly if you are interested in advanced MS biomarkers. You have these new biomarkers that are arriving first, maybe interest in cortical lesions. Now we have the central vein sign, we have the paramagnetic rim lesions. All these now in the McDonald criteria. And you have, of course, not only one time point, but several time points. So you can imagine this is a lot, and you have patients that are luckily, of course, staying more and living more and more, so you have more longitudinal time points. So it means now, if I'm putting more on the technical perspective from the machine learning task, you have a lot of tasks that you can deploy in this type of cohorts and data sets. And we can think about image quality, we can think about segmentation that I will mostly focus today, as well on the topic of classification or regression. And these are all different tasks that you can do in MS with AI. But today I will maybe take as an example the segmentation, where you will have a training of images, probably annotated, and then you will have a decision, a prediction. Is that point of your image a lesion or not? Okay, let's take this task. And then AI will provide you with such an identification and such a decision, and will tell you with 90% of probability that point of the image is a lesion. And this is the first layer of information that we could have, for instance, in the context of the segmentation of lesions in MRI, right? But is this everything? The idea that I want to convey today is that this 90% probability is not the whole story. And indeed, we cannot maybe stay at just that, taking that information. The idea there is the notion of certainty. And this prediction, it might be more or less certain indeed. And what I will talk about today is the fact that we can estimate this uncertainty at different anatomical levels as regards the patient, from the very basic point of the image to a patient level metric, and actually how this really can be used. And this is, if you want, this uncertainty, we see it as a second level of information that we can have in our studies or assessment of patients. So now I'm dipping more in a little bit the technical, and I didn't put the chrono, I'm sorry. So maybe stop me at 15 minutes, that someone says 15 minutes, Mary, because I didn't put the chrono. So some technical considerations that I hope they are understandable for everyone is that the first question that we might ask ourselves is why a system can be uncertain, why these models are uncertain. So of course we have sources from the data noise, because of the data acquired is noisy, because of the annotations that we have from several experts are sometimes noisy, in the sense that you have an intra and inter-expert variability. And for some of the MS biomarkers, this can be actually quite high, because they are really in the process yet of defining those biomarkers. So this is a factor. The second factor, it is data scarcity, right? Because indeed, often in the studies, you have several hundreds, in the best case, maybe 1,000 or 2,000 subjects, but this is relatively small or might be biased in the representation of the disease. So when you have a case that has not been represented well, this creates a domain shift in that sense. And domain shifts comes as well from a more technical perspective, because you are acquiring data in different centers, with different protocols, with different machines, with different magnetic fields, and so on and so forth. So all these reasons make the model, to me, might be uncertain. In the theory of uncertainty quantification in medical imaging, we like to distribute uncertainty into different groups. One that comes more from the data noise, and the other that comes more from the lack of knowledge on the model. And what it means practically, what are we talking about this uncertainty? Now, have this slide, and you have a deep learning model, whatever it is, whatever task. You have an input, X, and you have an output, Y, right? You are trying to feed that function, F. And to represent that function, you use what we call weights. We estimate in the process of optimization of any deep learning algorithm, what you are doing is really estimate the weights of your units that just are like the weights of filters that learn which is the best representation of your image to take a certain decision. Okay, I'm simplifying a little bit, but just for you to grasp the idea. The reality is that because of all the things I just explained or I just cited in the previous slide, you don't really have one weight, right? You have stochasticity, a lot of stochasticity, it's a difficult one, in this system. And indeed, you have a distribution of weights because of the noise, because of the lack of knowledge, and so on and so forth. So when you get only one output probability, you are just relying on one shot of weights. But in reality, you don't have one weight. You have a probability distribution of weights, right? And this is what it creates actually, if you want, a probability distribution in your outputs. In my case, is this a lesion or not, right? And now when you have this probability distribution of numbers, sorry, I forgot to say. So we have in medical image analysis, or in general in uncertainty quantification, a bunch of methods. And this slide is just to show you that you can choose whatever method you prefer the most in your case. In medical imaging, we often work with Monte Carlo dropout and ensembles. I will just touch a word in ensemble because it has been our choice. But you can choose whatever you want that fits you well. And the idea, as I was telling you before, is like in the output of a regression, you might have actually what this distribution here represented only by 3 values. In a classification problem with multi-class, you can have as well a distribution per class that you have in your image. It's not important. Once you have estimated this distribution of weights, you can now compute measures of uncertainty that often comes from information theory, like the entropy, the mutual information, or the variance. So the first step is to really try to estimate this distribution. The second step is to compute the measure of uncertainty, right? So you have here different choices. What we have selected is ensembles for different reasons. They have been proven already to be good in estimating the distribution of weights. And the idea is that if you take your tip, your model, your preferred model, and you don't touch anything, you just keep the same batches, the same input image, the same, exactly the same combinations. And you just touch the first initial random parameter that starts the optimization problem, you end up having actually slightly different models, right? Because this gives you this stochasticity. So this is quite impressive if you think about it. But the idea is that then at the test time, you can only test with 3 models, and you will still have different decisions. So you can, of course, still get a prediction from the multiple decisions, but you can as well now imagine, estimate at each point of the image the variance eventually that you get of the decisions. Okay, so we choose a model to estimate the uncertainty at the output, here in samples. We might have a measure, let's say the variance. And now there is the idea of how we measure that uncertainty is good or not. There is no ground truth, and these are not big news because often there is no ground truth in many tasks of machine learning in medical imaging. But the main hypothesis that we convey is that we believe uncertainty or high uncertainty values should actually represent a higher likelihood of error of my AI model. And this is what we wanted to convey. We started to in the community of MS, in the context of the lesion segmentation, again, we really wanted to standardize these and to set up a benchmark that could help uncertainty quantification metrics be evaluated. So we relied on gathering different public available data sets that are corresponding from different domain shifts, different scanners, different sites, different annotations, different disease stage, and we really worked on creating a training, a validation, a test in domain and a test out of domain setting, and we launched this scientific challenge. We as well proposed new metrics that were more adapted to MS lesion quantification, like the normalized dyes. It is interesting because it really balances the lesion load that might be different in between subjects, because MS can have patients with a small lesion load and patients with a lot of lesion dose. So these normalized dyes helps to balance this. And we proposed a concept that is called error retention curves to really evaluate on the different uncertainty measures were better or not. A lot of people is interested, and if you are interested, we have again a tutorial in 2026. And here in this QR code of Natalia, that she created a lot of cookbook where you can really test these tools and compute the measures and take the materials actually of the tutorials. About the paper, I suggested a paper today because the idea of Natalia in her thesis was that we quickly realized that uncertainty measures at the voxel scale were not so meaningful when shown to doctors. And the idea was that we understood we should bring this at different anatomical scales. Doctors doesn't want to see another image, another additional image. So of course, state-of-the-art methods took uncertainty at the voxel scale, like using a variance or mutual information or whatever measure you want, and they bring it at the lesion or patient level just by averaging, right? You take a region of interest and you average. The idea of the paper is that you can do it differently. The idea of the paper today, it was rather to rely on these binary masks that you have, because per se lesion segmentation, you can see it more in a sense of a structure and in a structural manner of the whole lesion mask and at the patient level. So we rather work on an intersection over union deviations of the different lesion decisions and lesion mask at the whole level of the patient. And these are the metrics that we presented. Here you have just an example of what it would be having the decision, the binary mask, what it would be to have a voxel-wise uncertainty. Here you can see you can have a lesion-wise uncertainty, so you could have kind of a ranking of lesions that are more or less uncertain, and you have a value, a overall value for the whole subject. Here, a low value of uncertainty, so it seems that the model seems to be quite sure about this one. So, important slide for today that I wanted to convey, it was like we are trying to move the paradigm of just using the outcomes of the AI models that here I presented a lot in the context of lesion segmentation, but applies to many other things. And in this project, we wanted really to move it to the fact that you have to consider the uncertainty or uncertainty. And for this, we have these different levels of steps, methods to estimate these weight probabilities, uncertainty measures that you can choose, which scale you want to represent, and so on and so forth. So to conclude, what we do with that. So from an engineering point of view, you can do a lot of things if you have quantified the uncertainty of your model. And I think this is something that is still maybe not so well known, though there is more and more interest on uncertainty quantification. It has been paper proven to really be using the uncertainty, and I will mention an example now as a quality control. You can use it as an outlier detection. We have been exploring in terms of explainability. It can help boosting the performance. I will show you an example. And there are a lot of actually things that you can do once you have this second layer of information that regards the uncertainty. So our experiences, how we integrated that in MS Explain. So we had this lesion scale uncertainty that we wanted to explore. And what we did, it was that we were at this point having as well ground truth. And we were wondering, what are those lesions that seems to be false positive, but that the model is super certain? What's going on? So we give back this to the doctor. And we found very interesting results. It helped us to understand that indeed 1/3 approximately of the bunch of lesions that we were providing, I think we were providing around 200 or something in those lines. 1/3 were indeed missed lesions, so the doctor could re-annotate them. Another third were kind of misunderstandings in between annotations on the way they were annotating the lesions. And some others, 1/3 was indeed really false positives. So then we took these corrected masks and we help in increasing the performance of the model by 50%. So this is just one example from a technical perspective on how uncertainty helped us guiding the doctor or the interaction with the doctors in evaluating the algorithms, right? Another very interesting one is the patient scale. The patient scale is one number, and just maybe something I missed to say, I'm sorry, is like uncertainty, of course, the way I present it today, it is with an ensemble of methods. So you need if you use a supervised approach, you need labels when you train the different ensembles. But when you infer, you don't need labels anymore. So to compute the uncertainty, indeed, you don't need the ground truth, right? So if you think now in a deployment setting where you will deploy your algorithm and you don't have any ground truth because you want to have the algorithm exploring that new case coming, the uncertainty is something that might be actually corresponding to the quality of the segmentation in absence of ground truth. And this is what I'm trying to show you here. So what the paper shows very nicely, it was like when you use a simply aggregation of uncertainty at the voxeler scale, and you correlate this with the ground truth mask that we had for the experiment, you don't see much. But when you see the proposed structural patient scale uncertainty with the ground truth, you see that there is actually a quite nice correlation. So it means that it can be used, and this correlation prevailed as well out of domain. So it means that it can be a proxy of quality control of your segmentation. And I'm happy to explain it again if it was not clear. And just to conclude, we are having as well a lot of effort to trying to link the uncertainty values to, on one side, which are the reasons that make the expert being certain or uncertain in the annotations. And on the other side as well, to features that come more from if you are familiar with the radiomics features, and other features that we can really measure based on the lesions and on the patient data. And these are things that we are really trying to explore to understand better what it is the information the uncertainty is carrying it. So this is my last slide, and I will give the floor to Delphine. I'm not sure if I was in the 15 minutes or more. Today, I really wanted to convey this image analysis for the support of diagnosis and follow-up and for the understanding disease mechanism. Eventually, I focus a lot on MRI. I focus on one specific task, but of course, you have to think big. We have to understand that it's not only about one image and one time point, but we have a patient trajectory, that there are other biomarkers that can be pulled into any AI model, and of course that this has to be handed then to the doctor. So the question would be then why this is not yet used by doctors, and I would like to stop here to let Delphine, sorry Delphine, I don't see how to stop. It's thinking. I can take questions in the meantime if you want. Là, I completely lost the thing. I don't know where to stop. Can the host stop for me or not? What is the stop screen thing?
I think Delphine can just take over now.
I don't know. On Zoom, you could not if someone was sharing.
I asked to take control, but I think someone need to allow me.
Attends. Sorry. I don't see. I don't want to leave. I don't want to touch things, but I don't see the controls. Give. Now I see it. It comes, Delphine. I told you before, it's lagging.
Now?
Yeah,
no. Okay. Now I see it. Okay, so maybe I just go back one slide. Yeah, can you all see my screen?
Yes.
It comes.
Okay, perfect. So as Mary mentioned, they developed very interesting methods that could nicely answer some issue currently for AI to be used in a clinical workflow. And just to make it short, something you might don't know, you know I'm Delphine, but what you don't know is that I belong to a very specific center, which is a design research center. And our objective as a design research center is to look what are the adoption factors of a technology. And in this case, what are the missing adoption factors and what we should do to make sure like this gets to where it belongs, meaning into the clinical workflow. So from that, we started at looking at what exists in the literature. And when we talk about bringing AI into clinics, while the literature is quite clear, performance is not enough. So there are still some key pieces which are missing. And for example, and Mary mentioned it already, we need to implement something which is called calibrated trust. We should not go completely blind, so clinicians must neither rely on AI uncritically, and they should not ignore system because they think they are not useful. So we need to find a good balance, we need to find an appropriate balance between when it's good and when it's not good. We also need to develop what is called appropriate transparency. In fact, currently, what is written in the literature shows that explainable AI focus mainly on technical details. But actually, clinicians doesn't need technical details. They need explanations that fit their reasoning and workflow. And it's especially true in clinical workflow because they are a lot under pressure. Then there is the regulatory framework, which is, of course, essential to make sure that we follow rules. And the problem currently is that there is some lot of stuff which has been put in place, but there is nothing, or there is a missing void on how we actually make it work in clinical practice. Another very important point is that we need to find a way to involve all the stakeholders. So I think, for example, in the project, Mary did it well. They involved clinicians, they involved engineers, but it goes even broader. I mean, we need to involve also people who are expert in law. We need to involve people which are expert in ethics, but also people who are designing the interface and also the patient. So, and how it is usually done is also an issue. It's because, we ask them only at the end. So we develop a system and then we test it. But actually, when we talk about involving stakeholder, it needs to be done like in a genuine way, not just symbolic, in the sense that we need to ask them early enough and involve them in the process. And finally, last but not least, as we say, those systems needs to be evaluated in real clinical context. And we need to make sure that we measure some usability, safety, and impact on decision making, but also impact on how people behave with such a system and feel with such a system. Okay. So I think this slide you already saw it. Mary showed it already. And I mean, there is some framework which exists to help researchers, engineers to create trustworthy AI in framework. And those frameworks are very important because they can be used as a foundations. But there is some missing information in those. And particularly when I talk about calibrated trust, participatory methods, and workflow integrated explainability. And why it's important to not forget the last point is that because if you do that, then you end up having a system which can't be used in clinical workflow. And this is the results of the paper so I've proposed today, which actually display that depending on the disciplines, so depending if you are a clinician, an engineer, a domain expert, so by someone in law, someone in ethics, or patients, you have different opinion and different needs about trust and transparency. So if you don't take that into account when you developed those methods, then you have, concepts which are different, and you need to have reconciliations. So that's I mean the main issue we think in the literature we found. And how we came up with these results. So this is exactly the paper. So it's currently a preprint. It's under review, so it's not yet being accepted. We'll see. But I wanted to show you this type of methods because you have to see it with the perspective of design research. So we are designer researcher. So me, I have a background in engineering, but in the team, we have people who have a background in design, people in background with cognitive science, so they know how to measure the user experience, and yeah, different type of designer, different type of engineers. And our objectives is first, when we start projects, to understand where will be the pain points, where will be the issue. And for that, we always start with what we call generative user research. So we go on in the field and gather some knowledge about the stakeholders. And for this, specifically, so in the context of Mary's work, we did it into 3 phases. And we started, so this is really the study design, as we call it. And we did 3 phases, and we started with people who are directly linked to the project. So people who are the researchers and the clinicians. Then we did a phase 2 where we expand the stakeholder perspective and ask people in design, in law, in ethics, also in AI, but also people who are doing annotations because they play a role in how AI is working, etc. And then finally, we also wanted to have the patient perspective. So we did a phase 3 where we created a workshop, where we did a workshop with people who are not patients, actually, who do not suffer from MS, but as everyone in the world, we all been experiencing medical care. So we took people in the lab public. So now I'm going to go into details for each phases. And as I said, the first phase focused on people which are directly involved in the MS Explain project. So we had in total 11 participants, 6 clinicians, 5 engineers, and we use semi-structured interviews. So semi-structured interviews are very interesting because you draft a script, you want to get some knowledge from the person who you are going to interview, but you leave it open, because some people will like to go into one direction, so you can go to that direction, but you have a script to follow because you need to ask the same question to everyone. And in this case, of course, we use 2 different types of scripts, one for clinicians, where we focused on diagnosis and workflow, and one for engineer, where we focused on development of integrations. So here it was super helpful for us as design researcher team, because we had no clue about the MS context, about like the designer had no clue about what is segmentation, what is MRI. So for them, it was also a way to acquire knowledge and the vocabulary. And I think it was also helpful for the team of engineers and researchers with Merit, because they were able to spend some time with clinicians in a formal way, and also to gather knowledge on how their methods can be helpful and really understand, okay, where this could be placed. Once we did that, so this phase captured real-world constraints and expectation from practice and development. Then we moved to phase 2. So after phase 1, we realized that AI involved more than clinicians and engineers. So we decided to include other type of stakeholders. And again, we did semi-structured interviews, and each time it was tailored to each discipline. And we wanted to have some definition of trust, some ethical and legal concern about AI, some recommendations of people who already did that, and understand a little bit the terminology like accountability and bias. So this phase helped us to, open the perspective into a system level and all the societal considerations. So then we did the phase 3, which is based on quite a different methods. as we say, we wanted to have the patient perspectives. And for that, we could have done semi-structured interviews, but we wanted to have access to emotional insight, how they feel, how they fear, and how they experience such a technology from their perspective. And for that, we asked people, like, so it was a few, 6 people, and it was like a 2 hours participatory workshop. We did different type of exercise, so which are called metaphor exercise. So, you know, people express picking some images, what they think of compared to what AI means. They also did some exercise of sense making. So, you know, there was a word AI, and then they had to connect it to different words. And also they also create. We like to do that. They also did an exercise where they had to build something, and you know, because this way they show like exactly what they feel in a different way about AI. And yeah, we collected different data, notes, photo, artifacts. So this phase is really important to access to emotional and tacit and experiential knowledge. So with all this data, we perform the data analysis, and for that we first, all the interviews were recorded and then transcribed, and we did a thematic analysis. So this is well-known method in this field. So the idea is that you extract theme from all the transcript you collected. Then we did some coding also. And we integrate all the results across the 3 phases. So we could have done it separately, but we thought each phases bring an additional knowledge. And this is exactly so this is like the graphical abstract of the paper, and it shows what we found, meaning, like, as I said at the beginning, people do not expect the same if they are a clinician, an engineer, or a different type of domain expertise of patients about what means trust and what means transparency. So basically, it means that trust is definitely not universal. So, for example, clinicians are very skeptical and they need a lot of verifications. Engineers want technical reliability and develop some metrics. The experts want to balance skepticism and acceptance. So you need to calibrate trust, not somehow, as an engineer will do, maximize it. Also, we don't have the same view on transparency needs. So what clinicians want, they want the locations, the lesions of the location, the locations of the lesions, sorry. So engineers want somehow how, like how the model is made, how uncertain is the model, and the patient wants to understand the impact that it will have on them. So what is interesting is that there is no overlap. So that's why some explainable tools fails, because, you know, what engineers, as we develop the method, wants is not exactly what is required. What was interesting also in the patient workshop was the idea of a double black box. So in the sense that for patients, the medical doctor are already a black box. So for them, adding one was not actually the problem. The problem was already there. They had the issue with communicating. What also we realized, and maybe this is also part of how our semi-structured interview were structures, is that when you discuss with the engineers and the clinicians and the domain experts, all the emotional part is a little bit missing from the discussions. And so, you know, there is like a real gap between what is important for people in the technique and how people lived the experience. So this is, yeah, what we get from this part. And somehow it's the beginning of the journey. So now we know that we need to find a way to reconcile all those views in a tool that can answer all the needs from the different stakeholders. Because, yeah, if you want your tool to be used in clinics, you need to make sure, like, the engineers agree to deploy it. You need to make sure the clinicians agree to use it, and that the people in law agree that it is usable according to a certain regulatory framework, etc. Anyway, so at this stage of the paper, I don't know if you see my mouse. Anyway, at the end of the paper, we are at this phase. So this is a scale of element of user experience design. And as design researchers, we go from the bottom to the top, and we start by eliciting user need and objectives. And this, we did it via what I just said, semi-structure interview and user testing. We are now needed to, once we have that, somehow, you need to understand, okay, what need to be shown and when it need to be shown and how it need to be shown. So this is what we did in another study, which is called a card sorting study, but I'm not going to talk about that today because we have no time, but it's what we did next. So once we have all what could be shown to the clinicians, we did a workshop with different disciplines, and we did a card sort study workshop. And basically, people use printed cards and discuss around the card and say, okay, this, I want to see it every day, for every moment, for every patient. This, it's not required for me as a clinician, but then the people maybe in engineering, but it's important because it will give you this information, etc. So it's a way to communicate and to find what will be the architecture of your software and the architecture of the informations that will allow you then to design the user interface. Okay, I think I will stop here. Mary, I don't see you, but you can tell me if you want me to move to the end of the slide.
I don't remember which is the end of the slide.
Okay.
Can you move forward?
Thanks.
Well, but no, that's fine. I think that's fine. Yeah. That's fine. Of course, yeah. Well, we work in MS since many years, and it corresponds to previous collaborators with doctors, and yeah. No, that's all. No need. Thank you.
Okay, so I stop sharing this way. I see you again.
Hey, thank you so much, Mary and Delphine, for your presentations. You were both quite informative for the subjects you picked to present us. Does anyone from the audience have any question? Yes, time. Go ahead, please.
Yes, I maybe already have one. First of all, thank you so much for your time. It's really great because I have the feeling that it aligns very well with what we are doing as a community and the creative approach, because I really want to applaud you for that. This is kind of extraordinary, right? In the research community, you don't see those aspects like emotion, visual card sorting, stuff like that. I think that really opens a new perspective on this domain. So I think that's really, really cool. Just to have said that. Maybe just to address Mary specifically, you were talking at, of course, distributions of uncertainty and like on a voxel level. I was just wondering, like, if you are working with deep learning models, how feasible is that? So I can imagine that you, for example, have a CNN and that you do inference maybe like n times, and that you will have a distribution across all the voxels. How computationally intensive is that, and like how can we justify the need against maybe just like that it's unnecessarily computationally expensive?
Yeah, that's a very good question, and I cannot tell you how much additional computational cost are you adding, but it's a very good question in the sense of balancing the computing efforts. With ensembles, I mean, it costs you retraining the model n times. We did it many times to see how many ensembles we wanted to have. Finally, with 5, you have already very good approximation, so you don't need to go beyond. Of course, the more you scale your model, the more computational is additionally, but I guess, yeah, I mean, I don't know. I would put in front having the uncertainty, even if it costs me a little bit more of training than not having it at all, because for me, then I'm missing an important information, and you will need anyway to retrain your model when you realize that it's failing and you don't understand why. At least with uncertainty, you can track, you can have this red flag that tells you, wait, now I'm a little bit away. Yeah, but you're right. It's a trade-off. I'm not so expert in many other ways. Monte Carlo dropout, I'm not sure if it's much more computational expensive or not. It really consists on during your training and testing to really disconnect some of the layers. So I guess this doesn't really need to have an additional computing time, I would say. I don't know, to be honest, these details, but it's a fair question to be asked when you choose your uncertainty quantification method.
Okay, thank you.
Maybe I can also just thank you for these wonderful talks. I really enjoyed indeed the overview of really linking it to linking your work to the needs of all these different stakeholders, and I think indeed, like Stein said, it matches very well with what we're trying to do as a community. I was wondering because especially Mary, with your talk focusing on the on lesions, do you see the application of uncertainty also being useful in specific other approaches?
Other tasks, you mean?
Yeah, other tasks. Yeah.
I think yes. I mean, of course in my work I usually develop models for segmentation, but for instance, one other task that corresponds as well to lesions, though, it would be this idea of supporting the CBS classification or finding CBS lesions or finding whether there are periels in a subject or in a group level. And in this case as well, having the uncertainty in this classification task, I think it's very relevant. And we are trying actually to link it to the uncertainty of the annotators because these biomarkers are quite new. So they are as well uncertain on the annotation. So of course, our hypothesis is that there is a link to some extent. But I think, I mean, in any other, I mean, there are, for instance, there have colleagues, I collaborated, but I'm not leading that. They are colleagues that explore MS through what they call brain age estimation. This is a regression task. But honestly, I think that having this uncertainty at that level on a margin, I mean, basically I'm selling uncertainty, but uncertainty is kind of a statistical value of the margin of error that you have in your prediction. So I would say I'm not inventing anything new on that, and anyone that is conducting studies should really want to have this type of error bars when they have their predictions. And I think brain age might be a very good field as well. If you think big on this mixing, and we are exploring this, but I could not show results yet. When you mix biomarkers, for instance, trying to predict, we are exploring how uncertainty could be combined. Uncertainty from MRI-derived biomarkers plus the NFL uncertainty, how these two combine can, for instance, predict, I don't know, the DSS scale. Okay, EDSS, it is what it is. It never correlates with anything. I know it's complicated, but in this type of settings where you are mixing as well multiple variables, for me, the uncertainty is kind of this statistics error bar on one of your variables. So when you are aiming at thinking big, doing this prognosis, so there are these studies of trying to at larger scale combining features and doing prognosis, I think having this information would be precious. So yes, I think it can be really beyond what the examples is because this is what I have in my slides. But yeah. And just something very basic as a quality of the segmentation, right? We conduct a lot of studies based on MRI, just segmentation as well of the tissues because I focused on lesions. But if you take brain morphometry is an important biomarker in MS as well, right? So only that, if you can think about that uncertainty could give you a certain level of accuracy of your segmentation, it can help you pinpointing errors in your groups. You see, so I think this would be important as well.
Thank you. Yeah.
Thank you, Tommy, for the question. And actually, what I've learned working with Delphine is that we should stop talking about uncertainty, because uncertainty is just the engineers. The doctors, they want to have certainty. So just for the joke, this is something of the things that you learn when you work with Delphine and her team in the course of the design.
Yeah, I mean, it's exactly what we find out when we did this card study workshop. That could be a next talk here in the communities, because it's the story continues. But yeah, that's why when you realize that we are not aligned on the same type of vocabulary, and this is the hard part to make sure everyone understands.
Stein?
Yeah, I will keep it short. I don't know. Do we still have a bit of time? If nobody really bothers that we are a bit over time, then maybe a couple of questions are still justified. Because
I just need to leave at 4:45, so in 15 minutes.
Okay, now we'll leave it very, very well. I make it very quick. So specifically, Delphine, I really liked actually on your slide that the clinicians are black boxes. So that's kind of the thing that I was. I couldn't unsee it anymore, and then I constantly during your talk I was keeping that in mind. Like I was wondering, like, how did people? How was that phrased more or less? Like, are they really like, do they see any difference? So for example, that the black boxness of a clinician is different from an AI. Do they feel that it is different, or is it just all black box and it's just for a patient, like, I don't know.
Yeah, I think it's also because we use the terminology of black box. And then they all came like, yeah, but anyway, when I go to my doctor, most of the time I don't understand what he's trying to tell me. So it's already a black box. So for us, I think it was also like, okay, how do you feel if you know, like the doctor is using AI to help diagnose what you have, and they say, yeah, well, it won't change a bit because I still don't know now. I still don't know why he decided that. Really, I don't understand it. And I mean, the sad part of the story is that when you say that to clinicians, actually they are quite aware of this issue, and they're like, yeah, but we don't have that much time to explain the patients. We have really short consultations. But I think it doesn't mean that we cannot do something about that. And maybe AI could play a huge role in translating what a medical doctor is telling to the patient. So that could be a plus for that.
Okay, thank you.
Okay, so Barantes has raised her hand.
Yes, maybe it's like a meta question for the film, like how you decided on the design of the, like first involving the clinicians and engineers, and then the law, and ultimately like the patients, and not the other way around. Like how, what's the reasoning behind that? And like if you learned something from that experience, would you change things?
I think first we needed to learn a little bit the field. So that's why we needed to discuss with the people who are working in the field. And the first people that we could have access to was Mary's team and the people working on the MS Explain project, including clinicians. And while we were doing that, we say, okay, we already are aware that there is a huge part of the stakeholders which is who are missing in our current interview. But to really understand which are are important and how, which questions you need to ask to them, somehow you need to be a little bit a better expert in the field. So that's why I recommend to start always like that, to start with your close collaborators somehow, and then expand for you to be able to address properly the question and ask the correct questions. Then, we are design researchers. So I'm in the field of semi-structure interviews, and how this is done and how you get statistical outcome of that is a little bit different from how we do it. So like our results, they are limited in a way because we don't have that many people. We didn't interview that many people, but still it helps us to identify where the issue will be. And that's how we use it, but some people in the field who does that every day will say like, okay, you are a little bit weak in the number of participants you have. Just as a reminder.
Thanks for the answer.
But there is other methods which exist. Sorry, I continue. Stop me if I should stop. Which exist to generate knowledge from your user, and this is one part of it that we like using because it also creates, create people around your project that you can also go back.
Brothers, please go ahead.
Yes, thank you. I have another very specific question. If someone else has a different question, it's fine to focus on that. But I was wondering about the certainty values that we get. Is that always the same as what a clinician would be certain about? So if we would look at the lesions that an AI model, for example, is having difficulty with or is less certain about, is that always the same lesions that a clinician will be less certain about, or is that very different?
We cannot answer that yet. We are trying to work on this. We have some work done currently on the revision, but it's public. You can read it. It's really on linking on what it make the expert hesitate and what it is the reasons why it thinks a lesion it can be or not. And they have a lot of hesitation, particularly for cortical lesions and depending on they are and so on. And we are trying to do this regression analysis to use these measures, but you need quantitative measures to do that in a way that you can say how much of the uncertainty is explained by the location of the lesion. And then we are trying to match everything, but I would not be very conclusive. And the models, of course, there is something linked to the errors that or differences that the annotators will be. So this will link to the two annotators annotating different, or one missing the lesion and the other not to some extent. But I think there are other things like image artifacts, distribution of the images that are more as well technical. So actually, if I'm not wrong, the quality of the image had a role as well. Yeah, but it's a very good question. As an engineer, this is what I wanted to know, like, okay, but why is uncertain, or what it is carrying more of the uncertainty measures?
Thank you. Yeah, my connection got cut off there for a second, so I didn't hear the end of your answer. But thank you. Yeah.
No, but I was saying that this is something that intrigues us as well, and we are really actively working to investigate that.
Nice. Yeah.
Okay, so I guess if there are no further questions, maybe we can wrap it up, I guess. Okay, so thank you so much, Delphine and Mary, for this presentation and the very fruitful discussion that followed this. I don't know, Stein, do you want to add anything?
No, I think so. Yeah, thank you for moderating the session, Smanla. That's very kind of you, and you did very well. Also, maybe just so every time I link it back to that, there's like a little Google Forms that we have on the events page. If you want, you can fill it in and you can give some feedback on how we can improve this. I think one of the things that came up is that we probably should more actively maintain some kind of mailing list so that we can make people easier up to speed with our journal clubs that are happening. So if you have any suggestions in that regard, you can just share them with us, and we can improve our journal club series with great talks like those two that presented today.
Thank you very much. Thanks for this initiative. Super cool, and for inviting us. And yeah, let's keep in touch for next steps together.
Right.
Yeah. Thanks for the invitation.
Okay. Thanks everyone for joining. Bye.
Thank you.
Thank
Bye-bye.
you. Bye.
Bye-bye.
Bye-bye. Bye-bye.